Hi everyone. The goal of this demo is to show you how to go from zero to cloud native ready in less than 30 minutes using our products. It is the V2 of this demo because our products are evolving very fast and we can already do much more than what we were able to do when I did the first version. So if you look at our portfolio very quickly, we have Mesosphere, D2iQ, which is our original platform, and that is used for everything as a service and big data use cases. Then we have Konvoy, which is like a Kubernetes distribution. We have KUDO, which is an open source project we have launched a year and a half ago, something like that, to be able to deploy stateful services on Kubernetes. We have Kommander that is able to manage the lifecycle of Konvoy clusters, but also manage permissions across clusters and so on. And Dispatch that is CI/CD platform based on Tekton and Argo. And obviously we have a training portfolio. We can deliver training that help people pass the CK and CKD certifications, for example. So if I go into a little bit more details, the way Konvoy works is that it deploys a pure Kubernetes cluster with all the add-ons that you need to operate it. So you get like all the add-ons for monitoring, for logging, Prometheus, Grafana, Elastic, Kibana. You get like the Velero add-on for the backups. You get the network add-ons like Traffic and MetalLB to expose your applications, and so on. So everything is packaged together. Everything is supported by us, and we make the upgrade from one version to another seamless. And another thing we do, which is really important, that we test that at scale. So we deploy like a cluster with 600 nodes, and on this cluster we deploy thousands of pods, hundreds of Jenkins master. We deploy Kafka, Cassandra, and Spark cluster. We are able to write like millions of messages per second on Kafka and Cassandra. We are able to launch thousands of jobs in Spark. So we really test that at scale so that we discover problems before our customers are doing it. We have Kommander that allows us to manage the lifecycle of multiple Konvoy clusters, but also allows us to apply permissions to multiple Kubernetes clusters in a very simplified way. So it's really unique because you have some other software today that allows you to simplify the way you apply permissions on Kubernetes clusters, but it's always one cluster at a time. So it's really unique the way Kommander does it. And Dispatch, which is our CI/CD platform based on Tekton and Argo, that make it really easy to adopt a GitOps approach. And I'll go through that in the demo as well. KUDO, we spoke about that, open source by us a year and a half ago, and make it really easy to build operators for Kubernetes in pure YAML. So a lot easier than any other operator framework you can find. So the goal of this demo is really to show you all of these things in less than 30 minutes. That's what I said in the title. So you'll see we'll deploy a Konvoy cluster, we'll deploy Zookeeper cluster, we'll deploy Kafka, Cassandra, Dispatch, all these different software in this demo. And to make it like in a way that you understand the value of each component, we use a demo that will get pictures from the Flickr API and store them on object storage cluster. Then this cluster will notify Kafka so that another microservice can register to this Kafka topic and be notified when there are new pictures. When it happens, then this microservice extracts the GPS location from the picture and store all the information in Cassandra, and we have a third microservice that is getting the information from the Cassandra database and expose everything in the front end. So this is like the workflow of this software that is composed of 3 microservices. But what we'll do in this demo is that we'll go through uh, each step, like from Kommander, deploying a Konvoy cluster, configuring all the permissions so that the users who is like the owner of this application has just the permission he needs to operate all the other different components. We use dispatch to build and deploy the different microservices, and we'll use KUDO to manage these stateful services. So let's get started. So first of all, we have our Kommander cluster running here. It's running on its own Konvoy cluster, its own Kubernetes cluster here, but this cluster can also be used for other purposes. And if you look at this cluster, you can see that you have, like I described before, like Grafana dashboards that help you manage your platform, having like a lot of dashboards for Kubernetes, but also even like for Elasticsearch to see the status of your Elasticsearch cluster, for Velero, so you see the status of your backups and so on. So we have our Kommander cluster here. We want to show different things like how we can use identity providers like ldap and OIDC and GitHub and so on. We want to show like how we can use different workspaces to deploy Kubernetes clusters for different business units, how we can deploy Konvoy clusters using what we call infrastructure providers, so AWS, Azure, and so on. So what we'll do is that we'll use the command line to do most of the different steps. So it's easier than retyping everything in the UI. And also it shows you how powerful it is in terms of automating everything. So what I'm going to do first is that I'm going to just like deploy a ldap cluster on this Kommander host. So if I do like kubectl get nodes, should be able to access my cluster. Yeah, so just deploying like my ldap cluster, and I can wait for it to be ready, which should not take more than a few seconds. And then what I'm going to do is that I'm going to create a user in this ldap cluster. You see I have a organization unit called users, and inside it I will create this user1 at D2iQ.lab, and I just give it a password that is password. So just like a very basic ldap environment. So let me do that as soon as this is ready here. Okay, so now what I'm going to do is that I'm going to create a secret on Kubernetes with the password of the admin user, which is admin, the admin user of ldap, that will be used by Kommander to manage authentication using this ldap cluster. So I'm just going to run this to configure ldap on Kommander. And in fact, what I'm going to do then, I'm going to go to the UI of Kommander so that you see what has been created. As I said, I could have done that directly from here, but it's just like easier to do that way because I don't have to type all of these things. But you see, it's just like a standard ldap integration with the ldap host, the user you use for binding and all these different things. So I now have my ldap cluster running, and I already have my Kommander cluster also configured to use ldap. And what you will see that is really nice is that when I will deploy additional Kubernetes cluster, I will not have to configure ldap again, because this Kommander host will act as a proxy for all the authentication requests. That makes it really insanely easy to manage authentication for your different Kubernetes clusters. So let me continue here. We have that ready, and what we want now is to be able to deploy a Konvoy cluster. So first of all, we want to create a workspace, and again, I'm just going to use these commands to do it. And what will happen is that I'll show you in the Kommander UI. You'll get like a new workspace here available. If I click here, you see workspace 1. And in workspace 1, I don't have any Kubernetes cluster, and I don't have any credentials. So what's nice also is that the workspace is used so that you can group clusters together for one business unit, for example, but also you can have, this business unit can have their own credentials for deploying clusters on-premise or in the cloud. So let me just do that. So I'm going to add my credentials. So it's already set, so I don't want to share the credentials in the video, so that's fine. And I'm just going to create a secret that has my credentials in it, and then I'm going to create this infrastructure provider. That way, what you see is that everything I do is just like creating Kubernetes objects. That's what we call CRDs, custom resource definitions. So by just creating Kubernetes objects, that has a consequence that Kommander that is notified that there is this new object created for him, and he will take the actions to create the different objects. So if I go on Kommander here, and you see I now have my AWS infrastructure provider, but still I don't have a cluster. So that's the next step. So I'm going to continue, and I'm going to just start that, and then I'll explain you how it works. So I'm just going to create one cluster here, and going back to Kommander, you see, bang, like I created a cluster just saying like this is a Konvoy cluster. I want to have this and these add-ons, and you see I have some add-ons for dispatch, for example. You can specify the version of Kubernetes, you can specify the region and the zones and the machines you want to use and so on. And that just triggers the deployment. And then you can follow the job to see, you know, how the deployment goes. And on Kommander, you can see it's being deployed here. I'm also going to just add the license quickly so that I'm able to show you how you can add other clusters from the UI. Okay, so I've added the license, and so it's interesting. So that what it means here is that if I want to get more than 2 clusters managed by Kommander, so the one from that where Kommander runs plus another one, it's for free. If I want more, then I need a license. And what I want to show you here is that I deploy that through the CLI, but again, you can put your YAML here so that you deploy your cluster, but you can also create a Konvoy cluster in a very simple way. If it's just a basic cluster, you don't have special configuration, then you can choose the region and availability zone and so on, and the number of nodes and the type of machine, and done. You just click on continue and it deploys it. So very simple. You don't have to, some other vendors force you to create your network in advance on the cloud provider before you can even deploy a cluster. Here it's not the case. Everything is done for you. As I said, you can follow the deployment here, and you see that currently it's Terraform deploying infrastructure, and after you have Ansible that is going to deploy Kubernetes and all the different add-ons, and we can just wait. So you can really automate everything. That makes it really powerful. You can have some testing where you automate the deployment of the cluster when it's ready. You automate the deployment of KUDO, and so everything I do now in the demo, I could do one script and does everything, and I have it in fact. So it's really powerful. So let's wait a little bit for this cluster to be ready. Okay, so we have now our cluster provision. So the next step, and you can see if you look at the logs here, that all the add-ons that we selected have been deployed. You see it here. You see the dashboard, obviously, but the traffic ingress and Elasticsearch and Kibana and Velero and even Dispatch that we've just deployed automatically from Konvoy as an add-on. So next step, we just configure the kube config for it. So just getting that way, and I'm now able to access the nodes. So these are the nodes of my cluster that I deployed on Kommander, and you can see here the cluster up and running, and you can access the add-ons here. If I click on Grafana, for example, you see the same dashboard that I presented for the cluster where Kommander is running. They are also available in this cluster here. And what we do as well is that in the Kommander UI, you can see also here Grafana dashboard, and it's another kind of dashboard where we get all the metrics from all the different clusters that are running. So you get like a central view of all of your clusters. So I just deployed one, and you can see here I have the details about it, but if I would have like 20 clusters, then I could have a global view of all my clusters on all the metrics. That's really powerful. If I continue here, now that I have my cluster running, I want to apply permissions. So we spoke about the workspace where we can group clusters. What we didn't speak about yet is this notion of project. So here, I'm going to create a project for that in that specific workspace. And again, I'm going to show you how it looks like in the UI. So if I go back in my workspace here, I can see now I have a project called project 1, and I associated my cluster to it. So I can have like 10 clusters in my workspace, and then I can create a project, and in this project can be associated to the 10 cluster of my workspace, but it can also, if I want, be associated to only 5 of them, based on a label or based on things like that. And this project is a global resource across all my clusters of that I select and associate with this project. And I see I have a namespace here. So this is a namespace that will be available on all the clusters of this project. Then I can create secrets that will be automatically created on all the clusters of this project, the same for the config map. And I can also create roles and apply policies. And that's what I'm going to do to provide a namespace admin role for my user 1 of my LDAP provider. So if I go there, I'm going to create what we call a virtual group for this user. So instead of associating that group with one user, I could associate it with multiple users. I could associate it with a LDAP group. So I could do things a lot more complicated, but here I just keep it very simple. And I'm going to create a role here to, and I will start by creating workspace roles, and then I will go to project roles. So basically, I can create some roles that will be applied to all the clusters of my workspace. So if I want someone to be able to get admin access on all these clusters, or being able to access to get the pods on all the namespaces of all of these clusters, or if I want also, so we speak about the permission on Kubernetes, but we also speak about permission on Kommander. If I want people to be able to access like the Grafana dashboard of all the clusters of this workspace, I will create workspace roles and workspace policy. If I want to apply permissions on this namespace for this project and all the clusters that are part of the project, then I will create projects, roles, and policies. So let's start by the access control at the workspace level. So I want, in my use case, to be able to have access to all the CRDs for this user. So I just create one where I say I want to be able to do get CRD, so custom resource definition. So that's a role I create for that. And I create it here. And then if I go on the access control here on the workspace level, I see now my get CRD. And if I see that I have that custom resource definition, and I can do a get. And as I said before, I could do everything graphically. I just make it easy by doing that by the CLI, by using kubectl. But I want to show you that you can do that in the UI. The beauty is that because you can do that with kubectl, you don't have to learn a new API or use new CLI. You just create Kubernetes objects, and it's translated by all these objects in Kommander. So I have my role here. Now I want to bind this role with my group, my virtual group. So I want to bind these permissions with my user, which is user1 at d2iq.lab. So I'm going to do that here. And if I go back on Kommander here, I see now on policy that user1 has been bound to this get CRD role. And I'm going to do the same for dispatch to give some specific permission and to be able to allow this user to access the dispatch UI. As I said, you can use it to apply permission to Kubernetes objects, but you can also use it to apply permission to access some part of the UI. And again, I'm going to just like do a bind between this role and this user. So it's really the same as what I have just done before. So I see that everything is configured correctly. Now let's move to project roles. So here currently I can see in my project here that I have some default roles, but you see I have no policy. I don't have any permission associated with my user. So I'm going to just give it access to everything, but it will not be everything in any cluster. It will be just everything in this namespace or in the namespace corresponding to this role. And I'm going to bind that at the same time, like I did before. And when it's done, then I should be able to see that in the UI as well. So again, you can apply permission, cluster role permissions at the workspace level, but you can then provide namespace roles, what we call project roles, here at the project level, which means namespace. And you see I am admin of this namespace. So I have all the permissions I need, and now as an admin, I'm still the admin, I'm not user one. So I'm just going to use this kubeconfig so that when I run kubectl command, I will run them as an admin of this cluster I just deployed. And as an admin, I will deploy the KUDO controller, which will allow the user to deploy Kafka and things like that. So as an admin, I'm responsible for deploying the controller, but then as a user, I'd be able to use it with just like these namespace permissions. The same, as an admin, I will deploy the min.io operator so that the user can deploy a min.io cluster. And I'm also going to just like update the dispatch ingresses so that I can use them. But that's just a temporary thing that will not be necessary in the future. And I'm going to get the IP or the URL of the traffic endpoints that will be used by the end user. And I can just take a look at it now and see how it looks like. Good. So that's all I need to do as an admin. Now the user with his namespace permission will be able to do everything he needs with just the permissions he gets. So as a user, you need to authenticate. Okay, so the way it works is that you go to this generate token page and you say you want to get a token for this managed cluster, and you log in with the identity provider, so by using ldap, and you get all the instructions to set your kube config. So I'm just going to do simple copy and paste here. And the beauty of it is that when it will expire, I will not need to do anything. It will just redirect me to the web page to authenticate again and refresh my token. And if I try to do kubectl get ns, I don't have the permissions for that. But if I try to do like get svc, same. But if I do that in my namespace, which is here, then I can do it. So what I'm going to do is that I'm just going to use this kubectl config option to set my namespace, my current namespace as that. So when I will do kubectl get svc or whatever, it will always, I don't have to specify my namespace here. You see, I just automatically use the namespace I want to use. So now as a user, again, remember the demo. We want to deploy like KUDO Kafka and KUDO Cassandra and other things. And I can do that now as a user because I have the right permissions. I'll just also keep this kube config here in case I need to switch again in the future. So I go and to deploy Zookeeper with KUDO is very easy. You just go and say kubectl KUDO install Zookeeper. This is my instance name, the namespace I want to use, and it starts to deploy it. And you can follow the status of the deployment that way. You see it's in progress. And what's nice with KUDO is that you have this notion of plan and phase and step, so you can really understand what's going on. And if I do a get pods, I can see that it's already creating all my containers. And I can just use that snippet here if I just want to wait until everything is ready. So it will be quite quick, so I'm going to wait here and just like deploy that second service, which is Kafka. And then while it will deploy Kafka, yeah, it's done already, you see. I will be able to explain you a little bit more about the way an operator is built with KUDO. So I just run this command here. Again, I can follow the status of the deployment that way, and I can wait for it to be finished. So that's what I'm going to do. And I'm going to go to operators here and show you the way it is built. So if I look at the source code, imagine you can go to the source code of an operator and you can understand it. That's beautiful. That's not something you can do with any other operator framework. So you have a params file with all the parameters and the default value, easy to understand. Then you have like an operator file that is also quite simple. So you see you define your plan, you have a deployment plan and a validation plan. In this deployment plan, you have like, you can see if it's in serial or in parallel, and then you have phases, and you have one phase called Zookeeper with a task infra and a task app, and then you have a phase non-validation with a task validation, you know. And basically here, you have the YAML files for each task. It's as easy as that. And then, if you want to know exactly what the tasks are doing, you just go, for example, the validation task is just like a Kubernetes object, a job Kubernetes object, with all the parameters you set and some logic inside it. But it's really, really basic YAML files. And you have the same for the stateful set, which is used in the deployment phase. So everything is just like pure YAML. And it's even better because you can go and create some meta operators. And I'm going to show you that in a minute. But before, I'm going to start the next step, which is to deploy Cassandra. So here, I think it should be ready very soon. I can look at my pods. I can look at the status of my deployment. And you see the consistency across the different operators, same command, same approach, and you see it's ready. So I'm going to start the deployment of Cassandra now. Again, very consistent. I can use the same command to follow the deployment. I can wait for it to be finished, to be ready. And I want to use that time to show you like a meta operator, what I call a meta operator. I don't know if it's the right term. But if you go to this Flink operator, we have a demo, and we build the demo with the operator, as a KUDO operator. So if you go to it, you can understand very quickly in the YAML file where we have these phases and steps and so on, that here, my deployment plan, I have a phase here that's called dependencies that will deploy Zookeeper, and then that will deploy Kafka. What does it mean? It means that I can take a look at these Kafka and Zookeeper files to see what these tasks are. And if I go there and I look at Zookeeper, you can see that it's just like a KUDO instance object. It's just like a Kubernetes object. And that means as well that instead of doing a kubectl KUDO install Zookeeper, I could create a YAML file with this content, and I could do a kubectl apply -f of that file, and it will be the same. So it's really powerful, really, really powerful. So again, waiting for that to be ready. I think it should be ready in a few seconds. It's really quick. You'll see that in a few minutes we will have like everything already deployed. You see like it's complete, it's ready. Now, I won't go through MinIO in details. So MinIO is like an object storage platform. I'm going to deploy an instance here. There is nothing to do with anything we develop at D2iQ, but for the purpose of this demo, I need object storage. So I'm just going to deploy it. And this operator is not based on KUDO, and because of that, you don't have a nice way to follow the deployment. You don't have a nice way to understand what's going on. The only way you can really follow anything is just like looking at get pods and looking at, okay, I have these 4 pods and they are currently not ready, basically. And here what I did is I just changed the service type. So I have a service type load balancer, so I can access my MinIO cluster from the external world. And here again, I'm just going to wait for everything to be ready. So just running that and waiting for that to be ready. Okay, so my cluster is ready, and I can go here and I can configure using MC, which is the command line for MinIO. I configure my host, and I just say that I want to notify Kafka whenever I have like a new. I just configure Kafka as a backend for notification, and then I will configure after it here. I'll create a bucket, and then I configure the bucket I associate it with this Kafka broker here, and that means that every time I will have like a new JPEG picture in this bucket, then I will be notifying Kafka. So I'm doing that here, adding this event and just making sure it's there. Here I will not go in the details about explaining that, but basically I have a GitHub repo that has my application code, and we'll go through that later in the demo. But I just need to update it so that it has the right MinIO endpoint, my Flickr API keys, and my namespace, and some modifications like that. So I just need to go in my directory here, and I run that, and I just apply the modifications. So now the next step, I have my data services up and running here. Now to be able to build my microservices, I need to configure dispatch. And the way I'll do it is that I configure a service account in my namespace again, and this service account will be associated with all my different secrets to interact with GitHub, to interact with Docker, and so on. So I just like give it like my credentials for GitHub. I just like log in with Docker and give it my credentials for Docker, and the same here for my GitOps repo. So really straightforward, just giving it all the permissions it needs. And because I provided access to this user to my dispatch UI, I am able to also log in this UI now. So let's try that. So I'm using another web browser because I'm already authenticated as an admin in the other one. So just like accepting all these certificate things. And here you see again I can log in with my ldap. User one, passwords, and I have access to it because I provided the permission before. And you see here, whatever I don't have like pipeline and repository created already, but I have my secrets, you know, for GitHub and Docker that I just applied. I just created. So if I go back here, I can create, so associate my repository where I have the source code of my 3 microservices to dispatch. And what will happen now with this command is that it will go and create a webhook on my repository. So if I go to settings here and I go to webhook, you see it has just created a webhook to notify dispatch whenever there is a change in my source repository here. And you see I have 3 microservices, Flickr, Map, and Photos, and I have the source code here for each of these microservices and a Docker file to define how to build them and so on. So going back here, what I need as well is to create the application on the Argo CD side, so on the GitOps repo. So you see I have my GitOps repo that's called Ksphere demo GitOps, and I have 3 microservices in it, and I just configured them here. So if I go back here in my dispatch UI, I can here go to my dashboards, and I can click here and access the Argo UI, and I see my 3 applications that are now configured. And if I go on my GitOps repo here, I can also see that I have like my 3 webhooks here for my 3 different apps, so that it will notify Argo whenever there is a change in my GitOps repo. And the GitOps repo, if you're not familiar with GitOps, the idea is really to put all the deployment specification in a repository and to track the changes and so on. So here you see I have my 3 microservices again, and if I go to the map microservice, I have a template file here that explains how this application, how this microservice needs to be deployed. You see there is a deployment, there is a service, there is an ingress, but it's still just a template file, and there is no, we don't know the image name yet because we didn't build it. So that's what we are going to do soon. So this is like the dispatch dashboard. We have already been through it here. And if I just refresh, I should even now see my repository here, and I can even look at the status of my pipeline. So we are ready to use it. So to use it, what we are going to do is that we are going to use like a dispatch file. And I'm going to configure it now, and then I'm going to explain you how it works while the build will be in progress, so that we don't lose too much time here. So I just need to change here my Docker ID. Just specify my Docker ID here and specify it here again. Oh, the first was the GitHub ID, and this is the Docker ID. And to trigger a change, I'm going to just modify each microservice. So for example here, I'm doing the same for map, then doing the same for, oops, photo. Okay, so I can just commit and a push, and you remember we have this webhook that will notify dispatch. And for the CI part, we use Tekton. So if I go back here on the dashboard and I can access my Tekton UI from here, and you see it is currently generating the pipeline based on my dispatch file. And that's generating all the Tekton objects based on my dispatch file. You see how big it is? This is everything that has been generated from my dispatch file. If I would use Tekton directly, I would have to write all this code. Instead of that, I've just add like a small file like that, where I can define my source repository and my GitHub repository. I can define my 3 applications. It's using Python here because it's like a Starlark, but we also support QA and other meta languages. And here I have like I create like a Docker image resource for each microservice. I have a test task, but just for the photo microservice. Then I have a build task, and I say if it's the photo microservice, I want to have the dependency on the test task. But you see, it's a for loop, so I don't have to repeat myself. I can just use the for loop to define my build phase that will build the Docker image. Then I have a deploy task here that depends on the Docker image as an input, and this was the output of this one, and my GitHub repo that deploys everything. And here I can define actions. When there is a new change in the master branch on this path for the photo microservice, then I want to run the test photo, and then I have a loop here for my 3 microservices to trigger the build and the deploy phases. So you see 58 lines of code, and even we have now libraries available, so I could even remove that part and replace it by 1 line using a new library we are launching now, and the same here. So I could even probably be less than 50 lines easily compared to hundreds of lines here on Tekton code. Okay, so my pipeline is running there, and you see the different steps with the build for each microservice, all the updates of the Docker images, and then in a few seconds we'll start to see the deployment phase going on, and that means we'll be able to go on our GitHub repo, and we'll be able to see new pull requests coming for these different microservices. So let's do that now. So if I go to my repo here and I refresh, you see the pull request. And for each pull request, what happened is that it took the template file and just like renamed the file without, or created a new file without templates, and also indicated the Docker image. I'm a little bit lazy, so I just like go to use the curl command here. So just like merging the 3 PRs. And what will happen now is that when the merge are done, Argo CD will be notified based on the webhooks I have shown before, and you see it's now applying it in production. So it's kind of applying what's in our GitHub repo in the Kubernetes environment. And you see this is the Flickr one, and you have the map one, and you see like the service and the ingress and the deployment and everything being rolled out. And if I do kubectl get pods, I see here my, so now to see my app, just need to get the URL here, and if everything is fine, we see all these pictures coming, and I can see my different sunsets from different places. Some are more beautiful than others, but if you wait a little bit, you'll see more and more pictures coming, and it will be, you see, like very difficult to access these pictures there. You can zoom, but that's far from being really a nice user experience. So let's say I want to improve that. So I have another version of it. I just like changed this HTML file here, and I'll do a push. And why I do that is essentially to show you two different things. One is that on the Tecton side here, I get a new pipeline generated and running. And what we will see here is that this new pipeline will be only for the map one, because when we created our dispatch file, we did a for loop, and we did that for each change on the master branch for the different passes. So because we just add a change in this path, then it doesn't have to rebuild everything. So whenever it will be finished, then it will create a new PR again on my GitHub repo, and I will merge the PR, and then we'll see how Argo is ending that. So let's wait for a few more seconds. Okay, so when everything is ready, finished, I can go back here, look at my new PR. That is just a small change this time, because just have to update the image here. So I can just merge this PR here, and then we can take a look at Argo, and you see it's applying a rolling update. So we'll not go through that in this demo, but know that we can, if we deploy Istio on Konvoy, then we support also Flagger, which means that instead of defining like an ingress object, I can define a canary object, and I can do like a progressive deployment. So I introduce only a few percentage of the new version, check the latency or whatever else, and then when everything is okay, I continue to increase the amount of new versions we have, and so on, until we switch to the new version completely. So that's also something we support. So if I refresh my map here, you see it's far better. I can now zoom in and select a nice French sunset if it loads, depending on these pictures. Probably my network here. This one is okay. The other ones are probably too big. So that's it for this part of the demo. Just to finish, I spoke about monitoring and Grafana and so on at the beginning here. What I didn't show you was that we can also provide we also provide nice dashboards for Kafka and Cassandra. So that's coming with the KUDO services. So if I go there and I can select my my docs here, I can, for example, show you Kafka here, and you see that I have my 3 brokers and a lot of nice metrics about it. I can I have also one for Cassandra, so I can check the status of my Cassandra cluster here. Yeah, by default it's 6 hours, so I can just show you that here. And as I said, you have like Elastic dashboard and so on, but you also have like dashboard for dispatch itself. You see the different events. We have like ones for Argo, so you really have like a nice view of the metrics of all of your different software that are parts of the stack, and like traffic and so on. So you get really all these interesting metrics. So we've been through the full demo. I hope you enjoyed it, and if you have any questions, don't hesitate to contact me, and thank you for watching it.